Okay, let's look at the homework 3.3, 3.4, number 4. Alright, so you have f prime of x is given here, and we want to find the interval on which f prime is increasing or decreasing. Alright, let's do that first. Alright, so we want to talk about increasing, decreasing. Of course, we have to take another derivative. So we take the derivative of f prime, so which is going to be f double prime of x is equal to, right, derivative of x squared is 2x, and derivative of 5x is 5, and derivative of negative 24 is 0, right? So we set this equal to 0, and you can see that we can find, let's see, a critical number. So let's see, subtract 5, so you have 2x equals negative 5, and then you can just divide it through by 2. So x is going to be equal to negative 5 halves. Right? So we can just look at the number line. Right? So you have negative 5 halves. Right? Look at the derivative of the first derivative, which is second derivative. Right? Try any number less than negative 5 over 2. So it's going to be like maybe negative 3. Right? If you put negative 3, it's going to be negative. Right? And if you look at anything bigger than negative 5 halves, I'll try 0. Then you have a positive derivative. All right? So it'll be decreasing here. So f prime is decreasing here and increasing here. Right? So let's type that in. All right? So it's increasing on negative 5 halves to positive infinity. All right? And then it's decreasing on an interval from negative infinity to negative 5 halves. All right. Then define the interval in which the original function f is concave upward. This one is actually when the derivative is increasing, so it's the same answer as the part 1. So it's negative 5 halves, because if the derivative is increasing, then original function is concave up. So we're gonna put that in there, and the concave down when derivative is decreasing, so it's negative infinity to negative 5 halves. All right, part C. Find x value of the relative extrema of f. All right, so we have to take the derivative, but it's actually we already have the derivative. All right, so you have, let's see, we set f prime. Actually, I'm going to just set this guy equal to 0. All right. Then we can probably factor this out. All right, so factored it out as x plus 8 and x minus 3 would probably do it. All right, so this will give you x equals negative 8 and positive 3. Right? So we can do a second derivative test. So if you have f double prime of negative 8. right? Which is going to be, we just need to know the sign. Negative 8 times 2 plus 5 is definitely negative, right? Which means that that's concave down. So we're looking at the f of negative 8 is a relative or local maximum, right? If you look at second derivative at the other critical number 3, right? 3 times 2 is 6 plus 5, it's definitely positive, right? So therefore, concave up shape. So we're looking at the f of 3 is a local minimum. Right? So we have that. So let's answer that. Right? Relative max is at the negative 8, and relative minimum is at the positive 3. Right? And find x value of the inflection points f. Okay, so then I have to look at the second derivative here and here. You can see that the second derivative negative means that the original function is concave down, and the second derivative positive means concave up. So you can see that there is going to be an inflection point at negative 5 over 2. So go over here, and it's negative 5 over 2. Right? Let's check the answer. Okay, it came back and looks like we could do everything correctly. All right, that's it. I hope that this was clear.